What's going on, everybody? Today we're doing a full charging system analysis on this 1993 Yamaha XJ600 Seca II. We're going to cover all the details. If you've got a charging system problem, whether it's a dead battery, a battery that won't charge, we're going to go over all of that in this video today. First thing you want to check whenever you've got a charging or battery related issue is the fuses. Fuses are located under the seat near the battery on this bike. After the fuses, you want to check the battery. The battery is simple, just get a multimeter and I'll show you how to walk through it. Next up is the stator. The stator hides behind this housing here and the wiring goes up and under the swing arm area there. We'll dive into that. We're going to go over all the specs for the stator because that's a troublesome part sometimes. Then we checked that our regulator and rectifier are working properly and outputting the correct amount of voltage when the bike is revved to 5,000 RPM. Finally, if you still haven't chased down your problem, you want to check out your wiring continuity. So, let's get right into it. Hopefully this helps you if you've got a charging system problem on an old bike like this. Before we dive into it, please smash the like and subscribe button down below. It really helps me out. Now let's go. Your fuses are located under your seat, so just pop the seat. Your fuse box is right here. To check your fuses, you want to set your multimeter to continuity mode, basically checking for resistance. My multimeter has a setting where it will beep when it gets continuity, as in connection. So now with your two probes, you're just going to go to the tops of each fuse here and make contact across the top. OL means open loop, and then when you make contact, it beeps and it will read out a resistance. Just check every fuse, make sure it's all beeping. And if every fuse beeps, you're good. If a fuse doesn't beep or doesn't seem to have a connection across, you'll see this little loop here that's like an upside down U will be broken. And that is the fusible link that a fuse operates on. Essentially, once you conduct too much current and electricity through this fuse, the loop will break and save the electrical circuit. It's also worth noting that if your fuse is broken, there's likely a reason why it broke. You could put a new fuse in and just repeat the problem and pop the new fuse. That means you haven't fixed the problem, which is likely a short to ground in that circuit. Next thing to check is your battery voltage. Your battery exists on this bike right next to the fuse box under the seat. Essentially set your multimeter to DC 20 volts and then put your negative on the negative, red on the positive, and you don't want to see anything less than 12.6. This battery here has been sitting on my bench for, well, the winter, and it's kind of lost a bit of charge, but 12.44 is certainly a safeable amount of voltage. It's best to put your battery on a tender over the winter so you don't let it drop below, 12.2, because once it drops between a certain point, these batteries have a hard time rejuvenating the chemistry they need to hold sufficient electrical charge. So don't let your battery go low over the winter and it'll last many years. Well, at least a few. These batteries that exist in a bike like this or the XZ6 and many other motorcycles of this era are called sealed lead acid batteries. And they're not really serviceable. The best thing to do that isn't the cheapest thing to do when diagnosing a charging system issue is just replace the battery and have a new, no problems battery that you can just rule out of the equation. Next up is your stator. Your stator exists behind this Yamaha covered cap here, 3 bolts to take it off. The wiring disappears in behind like this cover. It goes, you see under the bike there, under the motor, goes up around behind the engine and it pops out underneath here. There's a hole, you see the string of wires coming out, and these are the wires you're looking for. These 3 white wires is what leads from your stator into this connection here. We're gonna unplug it here and then probe it to assess its resistance. Okay, so measuring this pin here, we have 3 pins coming out. We've across these 2, across this one to the top, and across the right one to the top. Now on XJ bikes that are from 1992 1995 in the US and the UK, you want 0.32 to 0.48 ohms of resistance in the stator, but from 96 onward in the UK models of the XJ600, you want 0.24 to 0.36. So for some reason, in their later model UK bikes, they changed the resistance in the stator to a lesser resistance. Get your black in there. It doesn't really matter. There's no polarity to the system, so it doesn't matter where you put which probe as long as you get good contact. So you see we got 0.3 ohms. That means it's good for this bike. I'm gonna move my red one to the top one here. It's hard to get a stable reading with all this plastic in there. We got a 0.3 there as well, 0.3 ohms as well. The way a stator works is essentially it generates a 3-phase AC signal that gets sent to the rectifier, which uses diodes to convert a wave into DC voltage, which is just a straight line, no undulations in its voltage. So plug your stator back into the white port that goes into this boot here, and we'll move on. Next thing to check and connected to the stator is the rectifier. It hides behind this plastic here, so take off this fairing with a couple bolts right here, and behind this thing, and then we'll pop the side plastic off to look at the rectifier. This here is your rectifier and regulator. It does two jobs. Essentially receives the three-phase AC signal from your stator and converts it with diodes into a DC signal, so it's not a wave. And then within here, it regulates down the excessive amount of electricity down to 14 volts. But what you have to understand is there's really no servicing these. The only thing you can do is ensure the wiring's good, there's no corrosion at the pins. If you have a problem and you really want to go the extra mile, just unplug this, check the pins are clean, make sure the wires are all good, because these are your main power wires. The red wire is what heads to your battery and gets you charging power, and then make sure it's grounded through these bolts. I don't see a black wire coming out of this plug, so I would assume that the electrical ground is through these bolts, through the frame here, which in turn goes back to the battery through the ground strap. The next thing, and arguably the easiest thing to do to check the overall health of your charging system, is do a running test. Turn the bike on, hopefully it's up to temp, and you want to keep it at 5,000 RPM. So rev it or have someone hold the throttle, revved to 5,000 RPM so that the motor is spinning over. The reason we do this is so that you spin the stator or the component, the magnets around the stator fast enough to generate a lot of electricity. The spec for the charging system, the voltage measured at the battery with no load, basically means no headlights on, no other accessories on, essentially everything else unplugged. You should be able to hit 14.3 to 15.3 volts. But in a more realistic sense, when you've got everything plugged in, you have your nominal output should be around 14 volts and 21 amps. Could put a multimeter like this and set it to measure current and put it in line with the charging system and figure out how many amps it's producing. But the important part here really is the voltage. You should be seeing 14 volts at the battery with your multimeter set to probing DC under 20 volts. If it hovers around 13.5, maybe it's tired. It's possible that your battery is low on voltage and it's just sucking up a lot of electricity. So this is why I said in the beginning of the video that it's best to have a brand new battery to rule that out, because you could do this test with a really tired battery like this one if you could bump start the battery and get it started, and it might give you a low reading like 13.2, 13.5, and be like, shoot, there's something wrong with my charging system. But it's not actually, it's just your battery's sucking up all that electricity, and once the battery's charged, it would probably register 14 volts at 5,000 RPM if you were to measure it. The last thing to check is what's called wire continuity. Essentially, set your multimeter to resistance, or like your lowest resistance setting like mine with the beep function to tell you when something's connected, and start probing your wires, like from your positive terminal to your rectifier, and from your rectifier into your wiring that leads to your stator plug here, and from your stator, if you wanted to, you could take off the side cover and see if there's any corrosion happening on the stator inside here. You're essentially checking the electrical pathways all around the bike to see if you have a rust corrosion issue, a broken wire, a short to ground, a little mouse that's gotten there and nibbled away at the casing and causing a sporadic short. All of those things could lead to a real frustrating and problematic charging system. So if all these components check out fine, now you check your wiring with a multimeter and just go deep dive probing on all the things that connect up the charging system. That's a wrap on the charging system inspection on this Yamaha XJ600 Seca II. I hope this video helps you solve your charging system problem now that you're armed with all this information and knowledge about how to do it. If you have any questions, drop a comment down below. I do my best to answer all the questions. I hope with videos like these we can keep more older rides like this one on the road today. It's really cool riding around on an antique like this. It's pushing 30 years old now. It's pretty incredible to see that they're still around and kicking. Please smash the like and subscribe button down below. Thanks for watching, and as always, have a good day.